Hi guys, let's solve today's Leetcode problem, which is problem number 2553. Separate the digits in an array. It's an easy problem. Given an integer of positive integer nums, return an array answer that consists of digits of each integer num after separating them in the same order as they appear in nums. To separate the digit of an integer is to get all the digits it has in the same order. For example, the integer 10921. The separation of the digits is 10921. Okay. In this example, if you see, we have 13. So after separation, it will come as 1, 3 in our answer array. 25, 2, 5. 83, 8, 3. 77, 7, 7. So yeah, we have to just do like this. Separate all the digits in the order as they appear. Okay. Constraint, if you see, nums dot length is 10 to the power 3 and nums of I is 10 to the power 5. We are going to cover two approaches. One is brute and then optimal. We'll do slight optimization over here. Now let's see how we can solve this using brute force. So what is being asked in the problem? We have to simply separate the digits. So when we separate the digits 13, let's say, we know that we need to get this 3 and 1. Okay, and in our answer array, this 1 comes and then 3 comes. Okay, and then so on. So let's try getting what we can normally get using maths and what we normally do using modulo. So to get this digit 3, we normally do it modulo by 10. So we get it 3. Now to get further digits of a number, we divide this value by 10. Okay, so after dividing this by 10, we get it as 1. Okay, now for 1, when we do it modulo by 10 again, we get the digit as 1. Okay, now again when we divide this value by 10, to process further digits, we keep on doing until we process all the digits. So it came as 0, which means we have processed all the digits of this number 13. Okay, now if you see what we came across first, so when we first is when we came is 3 and then 1. Okay, but in our answer it required as 1 and 3. Okay, so what we will do, I mean, we start processing in this array one by one each integer value, and for each integer this is how we will get, because normal modulo operation, what we do, we process it like this. We start from getting this value and this value, but the order which we want in our final answer is the opposite, right? So what we will do, we will store these values into temporary array, and later on we can let's say, so this is the temporary array where I'll keep on storing. So it will look something like this, 3 1, but the order which I want is 1 and 3, right? So after storing this in temporary variable, I will start processing in this direction. So first I'll push this into my answer and then this. So in that way I'll be able to get my final answer. Okay, so yeah, that's all for this problem. Now let's check the code. So we have this answer array initialized and num as nums dot size. Now we are iterating on this nums to process each digit by digit, and then we will separate all the each numbers and process it digit by digit. Okay, so num is basically the integer in the array, and then we are taking this temporary variable. So we are processing until num is greater than 0. Okay, so while this num is greater than 0, what we are doing, we are pushing back this num mod 10, as simple as that. Then after that, we are dividing num is equal to num by 10, so that we can get the next digit of that integer. After the processing is done, our temporary array will contain all the digits but in the reverse order. So we need to process in the reverse direction. So j will start from temp.size minus 1 and it will go till 0, j minus minus. And an answer will keep on pushing this temp of j. And at the end we can return the answer that we have. Okay, so that is all that we have to do. Now if we discuss the time complexity for this approach, so first is this loop, the outer loop, that is n times, and then another loop that is going inside, that is about for all the digits, right? It is going iterating over all the digits. So we know number of digits in a number is nothing but log of n plus 1. So this is the formula for number of digits. Okay, and what can be our n? Basically nums of I, this is x, right? Let's write it x, number of digits in a number x. So what can be x? So nums of I can be at max 10 to the power 5. Okay, which means log of 10 to the power 5 base 10 if I do, so it will give me 5 plus 1 is 6, which means at max there will be 6 digits, and it is visible also, right? In 10 to the power 5 will have 6 digits. So into, in simple terms, I can write it as log of x. Okay. And space complexity, so we are taking this additional temporary array. So this answer array we won't count because we are returning this as part of our answer. This is the additional thing that we are going taking every time, the temporary thing. So we will, that will be the additional space complexity that we're taking, that was of size log x, because at every time it is storing the digits, all the digits of a number. Okay, so that is what the space and time complexity for this approach. Now let's discuss how can we optimize on this additional space that we are taking it with some small observation. So the key observation is here, if you see, we are storing 13, 25, 83 and 77. But after just normally iterating over these numbers and processing digit by digit, we get something like this, right? 1, 3, 5, 2, 3, 8, 7, 7, right? But what we want is, eventually we want it as 1, 3, 2, 5, 8, 3, 7, 7, right? Something like this. But we are getting it in this manner. Basically reverse of every digit that we want. Now let's say, what if instead of processing in this direction, we process all the values in this direction. So let's see what happens if we process it from backside. So we'll process this first 77. So 77 will look like 7 7. Then we process 83. So first, in while processing 83, we know that first value we get is at the ones position, which is 3. So 3 8. For 25 we'll get it as 5 2. For 13 we'll get it as 3 1. Now if you see, if we simply reverse this value, we will get this one, right? So this is nothing but reverse of what we want. 1 3, you see, 1 3 2 5 2 5 8 3 8 3 7 7. Okay, so this is just the reverse. So while processing, we process from backside and we got this value and we just did the reverse. So in this manner, we don't need that additional temporary array every time, which save overall space. So this is the same thing. Answer array we have initialized n is nums.size. Iterating over the given nums array one by one. This num is the every integer in the array, and we are just processing it. Okay, so here if you see, key thing to notice, we are processing in reverse direction. Okay, and we are in answer, we are directly pushing this value nums mod 10, and nums is equal to nums divided by 10 to process each digits. After all of this, it would have been in the reverse manner, so we need to reverse it. So after reversing, we can return the answer. Just to tell one more time, so let's say if it is 13 and 25, so if we process 25 first, it will come as 5 2, and then for 13 it will come 3 1. But what we wanted is 1 3 2 5, right? What we are getting is this. Now if we just do the reverse, we will get this, which is 1 3 2 5. Same, right? After reversing, so same, we have processed each of this from backside, okay, one by one, and then adding that, after reversing, adding that into our answer. Okay, so that's all which we do here. And same time complexity is same, we are processing each digits in this nums array, and for each of the nums, we are processing for each of our digits. A digit can be log of x, so O of n into log of x. And space complexity, if you see, we are not taking any additional thing. Answer is there, but that is part of our answer that we are returning, so we won't count that. Additionally, we are not taking anything here, just few variables, so it is O of 1. So yeah, that's about the space and time complexity for this approach. I hope you like this video. Stay tuned for next videos. Thank you for watching.